Okay, start the recording here. Okay, so here's a problem where we have x times y plus e to the y equals e. We have this equation, and we want to find the value of the second derivative at the point where x equals 0. All right, let me give you a moment to copy this section 3.5 implicit differentiation problem down. Okay, so naturally we're going to use implicit differentiation to work this problem out. Again, we want to find the value, the second derivative of y with respect to x at the point where x equals 0. Okay, so we do implicit differentiation, meaning so we take the derivative with respect to x of both sides of the equation, and the derivative of a sum on the left is the sum of the derivatives. And then the derivative of x times y with respect to x, I'm going to use the product rule. Okay, so let me give you a moment to copy that down. Yes, thank you, Ian. I have an error right here, but all right, I got it right below. Hold on here. So class, this should be a 0 here. On the right side, the derivative, thank you, Ian. The derivative of the constant e is equal to 0. So please make sure you have a 0 there instead of a 1. Okay, are there any questions up to this this stage? Okay, Nicholas is good. All right, well, let's continue. Let's continue. So now, yeah. So now, just see here. All right. So this equation has y prime in it. How am I going to get y double prime? What am I going to have to do to this equation here in order to get the x derivative? I have to differentiate again. That's Radian. And so that's what we do here. So I'm going to differentiate again, so I'm able to get a y prime in the equation. Right, so take a moment to look over the work. I think it's pretty clear. Sometimes it's good just to have you all look at it. Okay, are there any questions so far? All right, so as you know, what we want to do is we want to group together, our second derivative, the terms that have the second derivative, because I'm going to solve this for y double prime. So I got to group together the terms that have the second derivatives, and that's what I do over here. Okay. And then the other terms I will bring over to the right-hand side. So that gets us down to this step here. Okay, let me see. Rodrigo wonders how I got the second line. Rodrigo, you're talking about this line here that I'm putting in green. Is that correct? Okay. So the derivative of the sum is the sum of the derivatives. So I have three functions here being added together. The derivative of y is equal to y prime. Okay. The derivative of the x times y prime, I'm going to use the product rule on that. So I'm going to get derivative of x is 1 times y prime, plus then leave the x alone, take the derivative of y prime with respect to y, that gets you y double prime. And then finally, the derivative of e to the y power times y prime, also going to use the product rule on that. So the derivative of e to the y with respect to x is e to the y times y prime. That's the chain rule you're using there. Times y prime, that's the second function, leave it alone. Plus then leave the first function alone, e to the y gets left alone, and the derivative of y prime is y double prime. Okay, good. You're welcome. All right, let's see if there are any questions down to there. Okay. All right. May I move to the next page? Are we good? Okay. All right. So now I'm going to take this equation here and solve it for the second derivative. So I do that. I solve it for the second derivative by, let me see here. Let me just double check one thing. Yeah, I have to divide by x plus e to the y power. And so I do that. So then y double prime, the second derivative of y, is equal to -2 times y prime minus e to the y times y prime quantity squared over x plus e to the y. Remember in the original problem, they say they want you to find the value of the second derivative when x equals 0. All right, so they're looking for a number. They're looking for a slope. Well, they're looking for, be careful here. Let's just keep it simple. They're looking for the value of the second derivative. Well, the second derivative by this equation here is a function of y prime, y, and x. I mean, it's ultimately a function of x, y, and y prime. Well, x we know because x equals 0. But now we have to figure out, what's y? What's y going to be, and what's y prime going to be when x equals 0? Okay, so what we have to do is we have to go back and solve for those, for y. First, let's focus on y. The original equation was, remember, the original equation was x times y plus e to the y equals e, right? This was your original equation here. So what I'm going to do is I'm going to put in x equals 0 for x, and maybe I'll be able to solve for y. And actually, I am able to solve for y because I get e to the y equals e, but e you can think of as just e to the first power, right? That's a 1 there, first power. And so y equals 1. Now you solve for y. Now the next step is to solve for y prime. Find the value. So we found the value of y when x equals 0. Now we got to find the value of y prime when x equals 0. And so I go back to the equation that we had for relating y prime. Remember, we had that, hold on here. Yeah, I mean, well, I'll write it. We had 1y plus x times y prime plus e to the y plus e to the y times y prime equals 0. Okay? All right, we had that equation from the previous page. 1 times y plus x times y prime plus e to the y times y prime equals 0. And so now what I'm going to do is when x equals 0, of course, I'm going to fill in 0 wherever I see the x. So there's the 0 where the x goes. But then the value for y when x equals 0 is 1. So wherever I see a y, I'll put a 1 in. Well, conveniently, that's going to allow me to solve for y prime. It's 1 plus e to the y prime power. No, that's not right. 1 plus e times y prime equals 0. So y prime will equal negative 1 over e. Okay, take a moment to look at that. Okay, are there any questions so far? Any questions so far? All right. All right, well then let's go ahead and move to the next page. So now, well, actually, hold on. Remember again that this is our second derivative. So again, the second derivative, we want to evaluate it when we want to find its value when x equals 0. Well, now we know what y prime. Y prime equals negative 1 over e, right, when x equals 0. And y equals 1 when x over 0, and x equals 0 when x equals 0. So all the variables and the derivatives, we can substitute their values in. And so when x equals 0, y double prime equals this expression, or, well, this value when we put in the values. So take a moment, look it over. Okay, and naturally, we want to solve this a little bit more easily. I mean, we could write that y double prime. We could say, I mean, we could put in WebAssign. Hold on here. We could put in WebAssign this answer. But why not simplify it a little bit? I mean, why not? So when x equals 0, y double prime will equal 1 over e squared. Okay, are there any questions at all on that? All right, everybody's comfortable? All right. All right, very good, very good. All right, so I want you to just pause for a moment here. I corrected my solution to that problem we were looking at. I'd like to do it. So just give me a moment. Okay, so again, this is the this is the problem that a few of you have told me you had a little difficulty with last night. And so now it is an interesting problem for sure. And as you know, when the due dates are passed for assignments, you're able to look at the key for the solutions for the exercises. You're able to bring up the key. And of course, if you're doing a late extension, you don't want to click view key because then you can't get the late extension. But you know, the late extensions all end tomorrow. So certainly tomorrow at 3:55 p.m., you could go back and view the key for any of these recent assignments. And my answer is going to differ a little bit from what the answer would be that the author gives, but it's still the same answer. Effectively, it's the same answer because of this equation here. So, all right. So we want to find the derivative of y with respect to x, where we have the tangent of x minus y equals y over 1 plus x squared. So, okay. We have to differentiate both sides with respect to x. That's how I like to do it. And on the left side, the derivative of the tangent of x minus y, we're going to use the chain rule. So the derivative of the tangent function is secant squared. So you have secant squared of x minus y. But then you need to take the derivative with respect to x of what's inside here. So the derivative of x minus y is 1 minus y prime. Okay, thank you, John. John caught that. And then the right-hand side is as you see. So the right-hand side, we had to use the quotient rule on the derivative of y over 1 plus x squared. Well, so, you know, that's, the quotient rule is f prime g minus, it's f prime g minus f g prime all over g squared. Okay. And so what I do to both sides of this equation, again, the goal is to solve it explicitly for y prime. You want to find the derivative for y prime. You couldn't explicitly find the derivative for y prime from the original equation. So that's why we're doing the implicit differentiation so that we can find an expression for y prime. But naturally, I mean, what I want to do here is multiply both sides of this equation by 1 plus x squared quantity raised to the second power. That's what we're going to do here. We have to do that in order to solve for y prime. And when we do that, of course, we get simplification here. And then you're going to get, now you don't have a fraction anymore in your equation. You just have, you know, an equation without fractions. And what I choose to do here on this step is I take the 1 plus x squared squared and I distribute that to the secant squared. No, hold on, that's not right. That's not right. One moment. One moment. It's almost right, Kelvin. Almost right. I mean, the math is right, but what I said was wrong. I'm actually taking the quantity 1 plus x squared times secant squared of xy. Now I'm going to distribute that to the 1 and to the y prime. And that's how I get this expression on the left side here. So let's make sure we're good down to that step there. All right, well, if we're good, we know what we need to do is we need to group the y prime terms together. So you have two terms involving the first derivative, y prime. You want to group them together on one side. I'm going to choose to group them together on the right side, as you see here. And then the negative 2xy on the right side, I'll bring it over to the left side. So what I did was I added 1 plus the quantity 1 plus x squared secant squared x minus y prime to the right side. And I added then from the right side, I added a 2xy. I want to say this the right way. I mean, so I added both sides of the equation. I'm talking right here, this equation. I added the 1 plus x squared secant squared x minus y prime term to both sides. And then I added a 2xy term to both sides. And then that got me down here. And now I'm able to isolate. Well, what I'm going to do is factor. I'm going to factor out on the right side the y prime from both sides. So here's a y prime, and here's a y prime, and I factor that out here. And so I get this expression on the right side. Are there any questions on that so far? All right. All right. Are we ready to move to the next page? Thank you, Betsua. Thank you, John. Okay. All right. I'll wait a little bit. One moment. All right. Are there any questions at all? All right. Are we ready to move on to the next page? Okay, very good. Very good. Nicholas has a question. Yeah, so Nicholas, you could have multiplied by the quantity 1 plus x squared in the beginning, and then you would have had, you could have rewritten the equation. You could have multiplied through by, actually, hold on. What Nicholas is saying is, when we had the tangent of x originally, original equation, well, our equation was tangent of x minus y equals y over 1 plus x squared. And he's saying, could have we written that as 1 plus x squared times the tangent of x minus y equals y? We could, and that's what the textbook did. We could do that, and then when you differentiate, you won't have to use the quotient rule. You absolutely could do that. It's just not something that I thought of when I did the problem. But it's a good point. And you know, for your exam, you know, there are different, you know, like there's some, like, you know, you could do that and then differentiate instead of, you know, using the quotient rule the way I'm doing it. That's fine. So now I'm going to divide by this factor here in front of y prime. I'm going to divide both sides by it. And I end up getting this expression. Okay, and then what I decide to do is I decide well, what I decide to do is multiply the numerator and denominator by 1 over 1 plus x squared. One over 1 plus x squared. On the top, multiply by that little rational function on the top and the bottom. And by doing that, I will get this. I will get this expression here, and that is correct. But they make note in the book, if you like in the book, this expression here, since the tangent of x minus y equals y over 1 plus x squared, this is the same by virtue of the original equation as, hold on here, as 2x times the tangent of x minus y. It's really an amazing problem. How many maybe got something like that, an answer like of this, like this form on your, when you did your homework, those who got it right? Okay, Ian did. Thank you, Ian. Thank you, Zoe. Okay, and thank you, Nicholas. And Ian says it accepts it unsimplified. So I would hope, like my answer, the 2xy over 1 plus x squared, it would accept that, as opposed to the 2x times the tangent of x minus y. But did anybody like have it? Did anybody have it as 2xy over 1 plus x squared? This part, and submit the solution that way, and it gave the right answer. It counted it as correct. Did anybody submit it like this term here, 2x, instead of like this term? Did anybody have their answer exactly as I've written it, with the term here, 2xy over 1 plus x squared? Did anybody have it that way? And then that WebAssign take that answer. It should have, but well, it should. Okay, so are there any questions on this? Any questions at all before we move on to section 3.6? All right, let me stop the recording.